Hello guys, welcome to today's video where we tackle a key software development principle. Hard-to-test logic is a code smell that needs fixing. We'll explore this through a practical example in ASP.NET Core WebAPI using Csharp. I'll show you a bad code example that's tough to test, refactor it into clean, testable code, and demonstrate how to verify it with a simple unit test. All code samples are included in the description for you to follow along. Let's dive in and make our code easier to test and maintain. Explanation of the code smell and refactor. The problem: hard-to-test logic in isPromoActive. The bad code in the isPromoActive method has a subtle but significant issue. Why is this a code smell? First of all, dependency on datetime. Now the method directly uses DateTime.Now, which returns the current system time. This makes the method's behavior dependent on the actual time when the test runs, making it unpredictable and hard to test. For example, if you run a test at 8 a.m. it returns false, but at 10 a.m. it returns true. You can't reliably test both cases without manipulating the system clock, which is impractical. In the second, lack of control. Since DateTime.Now is a static property, you can't mock or stub it in unit tests without complex workarounds, for example, wrapping it in a custom class or using third-party libraries. And finally, testability issue. The tight coupling to the system clock means you can't isolate the logic to test specific scenarios like checking behavior at 10 a.m. versus 8 p.m. without external dependencies. This hard-to-test logic is a code smell because it violates the principles of testability and dependency inversion. Good code should be easy to isolate and test under controlled conditions. The fix: refactored is active method. The refactored version introduces an iClock interface to abstract the system time, making the code testable and decoupled. How does this fix the code smell? Abstraction with iClock. The iClock interface defines a contract for retrieving the current time, UTC-Now. The system clock class implements this interface, wrapping datetime UTC-Now. This abstraction allows you to inject a mock or fake clock during testing. Dependency injection. The promo controller constructor accepts an iClock instance, which is provided at runtime, like system clock in production. This follows the dependency inversion principle, making the controller independent of the concrete time source. Testable logic. By injecting iClock, you can control the time returned by UTC-Now in tests, enabling you to simulate any time of day without relying on the system clock. Improved readability. The refactored code uses a more concise COR pattern, is more than 9 and less than 17, and a clearer method name, isActive versus isPromoActive, improving maintainability. The logic remains the same, returning true if the current hour is between 9 a.m. and 5 p.m., but it's now decoupled from the system clock, making it easier to test and maintain. Unit test for the refactored code. The unit test verifies that the isActive method behaves correctly when the time is within the active promo hours, 9 a.m. to 5 p.m.
Explanation of the test. First, setup or arrange. A mock iClock is created using mock, a popular mocking library for .NET. The mock is configured to return a specific date time, January 1st, 2025, 10 a.m., UTC, when UTC-Now is called. This simulates a time within the active promo window, 9 a.m. to 5 p.m. A promo controller instance is created, passing the mocked iClock object. It is time for execution, or let's say, act. The isActive method is called, and the result is cast to an OK object result, since the method returns an OK response with a Boolean value. And at the end, verification, or assert. The test asserts that the result's value is true, confirming that the promo is active at 10 a.m. Why this test works? The test is deterministic because the mock iClock provides a fixed time, eliminating dependency on the system clock. It isolates the logic of isActive, focusing only on the controller's behavior given a specific input time. The test is simple and focused, making it easy to maintain and extend. For example, we can add more test cases for times outside 9 a.m. to 5 p.m.
Why this matters?
The original isPromo active method was hard to test due to its direct dependency on DateTime.Now, which made it impossible to control the time in a unit test without hacks. By introducing the iClock interface and dependency injection, the refactored isActive method becomes testable. You can mock the time to test any scenario. Maintainable. The code is decoupled from the system clock, making it easier to modify or extend. Reusable. The iClock abstraction can be used across other parts of the application that need time-based logic. This refactoring aligns with SALID principles, particularly dependency inversion, and makes the codebase more robust. The unit test demonstrates how easy it is to verify the logic once the code smell is fixed.
This example shows how a small change,
Abstracting a system dependency, can significantly improve testability and code quality, making your development process smoother and more reliable.
That's all. Thank you for watching. See you in the next videos.